Now, and we go on to the next. We go on to the next page. The thing now is, if we know the length of the generating curve, we can and then we know it is we create an area that is something like a lake. So we can know the area of the revolution. So for theorem 1, that we can determine the area from the length of line length. So it is from line to a surface area. And for theorem 2, it is if we know the generating area, that we know the area that generates the curve, that is area, that we will know the volume of revolution. Okay. So for theorem 1, it is if we know the length of the line, and then we rotate it about x-axis, we can know the area of the surface area of the whole shape generated by this line. And for theorem 2, if we know the area, for theorem 2, if we know the area, of the whole shape and the centroid, y bar, and if we know the area of this shape, and then we rotate it, we will get a volume, and we will know the volume of this shape. And let's take a look how it is done. Now, let's talk about theorem 1. The area of surface of revolution. Let's talk about the equation first. It is L times 2 pi y bar. So here we have the multiplication of 2 pi L and y bar. So in English we will say this: there's something, the area of surface of revolution is equal to, and it's equal to something times something. It's okay. So this one means is equal to is 等于嘛 times 是长。So the area of surface of revolution, the area is this one, right? Is equal to the length of the generating curve. The length of the generating curve, length is 长度 of the generating curve here, which is L. Times, okay, revolution, very good. Revolution here means, of course, in the dictionary you have two explanations. If you look up a dictionary, revolutions means 转一圈。 or another in politics it means 革命哈。And the name of the theorem. This is a theorem. It has a name look like this, and don't ask me how to pronounce it. 我不知道怎么读哈。那 and so because it is by rotating a line to get the area, or by rotating an area to get the volume. So we call this surface or volume of revolution. So the area of surface of revolution is equal to the length of the generating curve times the distance traveled by the centroid of the curve while the surface is being generated. So the centroid of the curve is this one, and the distance traveled is the走过的距离。走过的距离。So while the surface is being generated, so by generating an area from this line, the centroid goes from here to here, because this line goes from here and then goes one revolution to get the area. So the centroid also travels for one revolution. So this is y bar, because the center is located at y bar along from the axis of from the rotating and the rotating axis. So the distance traveled is equal to 2 pi y bar. I think this is clear. So here it means if you want to get the area here, area by generating something like this, then it is equal to the length of the generating curve here times the distance traveled by the centroid. And for this is the first part of the theorem. The second part is from area. That to get the area, to get the volume from the area, we first determine the centroid of the area, and then we multiply. The volume is equal to the area times the distance traveled by the centroid. Now I think it is okay. It's 10:56 now, and on Tuesday I will talk about two examples. One is I will talk about one example, the one below. This is and we want to determine the surface area of the chain length. A chain length which looks like this, and we want to determine its volume. Okay. So on the so let before we I will talk about it next Tuesday. And for this shape, it looks like a donut. So what is this called in mathematics? Because it of course in daily life we call it donuts, right? And in mathematics, it is just for you can take a look. That is called a torus. And for the right hand side, it is called a cylinder. 圆柱哈，圆柱是 cylinder。This is more important, and the one for the left is just for you to know. And we will talk about this example on Tuesday.